Rarely in organic chemistry there is a happily ever after. Things are never settled, and a chase or a pursuit is always involved. Once the atoms tie a knot as a covalent bond, the electrons holding the atoms in place becomes the next major concern, so much so that it determines the outcome of most organic reactions. One begins to ponder over these electrons. Are the electrons happily and evenly distributed between the two atoms? If not, then who has the major share and why? What is the impact if the electron share is uneven? In an event where the electrons are displaced far from the usual location, beyond those two atoms in a covalent chain, then we are left to face more challenging questions like how they got there, who displaced them, and whether they are happy and stable in the new location. Who are its neighbors? Will they help stabilize the electrons? And so on. So the chapter Electron Displacements in a Covalent Bond on curlyarrows.com tries to address all these major concerns. The chapter covers in depth all the electron shifting effects that drive chemical reactions. The common ones are electronegativity, inductive, resonance, and hyperconjugative effects. Electronegativity is when two atoms holding the covalent bond in place do not share the bond electrons equally. Such a mismatch can create opposite poles that are a starting point for many chemical reactions. In inductive effect, the electron density is imagined as shifting along three or more covalent bonds. An atom or a group of atoms is thought to push or pull the electron density across this distance. Such a shift can positively or negatively impact molecular reactivity. Resonance is when the pi electrons take off and move across the covalent bonds. It is also responsible for generating doppelgangers, aka multiple Lewis structures. When sigma electrons think of moving close by, the effect is hyperconjugation. Both resonance and hyperconjugation effects have a huge impact on molecular stability. Curly arrows made sure that atoms were responsible for sharing the electrons. It has a chapter on formal charges and is a bookkeeping method to keep atoms accountable. Here, we calculate every electron transaction and its net effect on the molecule, whether it develops any charge, positive, negative, or neutral due to it. In short, the chapter offers a bird's eye and also a zoomed-in perspective on the electron chase. Do check it out. For learning chemistry, our imagination should be vivid and the pursuit fun. So I agree with Johann Goethe when he says, if you wish to draw pleasure out of life, you must attach value to the world.